James Watt was born January 19, 1736, Greenock, Renfrewshire, Scotland, died on August 25, 1819, Heathfield Hall, near Birmingham, Warwick, England, was a Scottish instrument maker and inventor whose steam engine contributed substantially to the Industrial Revolution. Watt was also known for patenting the double-acting engine and an early steam locomotive. He was elected Fellow of the Royal Society of London in 1785. Education and training. Watt's father, the treasurer and magistrate of Greenock, ran a successful ship and house-building business. A delicate child, Watt was taught for a time at home by his mother. Later, in grammar school, he learned Latin, Greek, and mathematics. The source for an important part of his education was his father's workshops, where, with his own tools, bench, and forge, he made models, for example, of cranes and barrel organs, and grew familiar with ship's instruments. Deciding at age 17 to be a mathematical instrument maker, Watt first went to Glasgow, where one of his mother's relatives taught at the university, and then, in 1755, to London, where he found a master to train him. Although his health broke down within a year, he had learned enough in that time to work as well as most journeymen. Returning to Glasgow, he opened a shop in 1757 at the university and made mathematical instruments, for example quadrants, compasses, scales. He met many scientists and became a friend of British chemist and physicist Joseph Black, who developed the concept of latent heat. In 1764, he married his cousin Margaret Miller, who, before she died 9 years later, bore him 6 children. The Watt engine. While repairing a model Newcomen steam engine in 1764, Watt was impressed by its waste of steam. In May 1765, after wrestling with the problem of improving it, he suddenly came upon a solution: the separate condenser, his first and greatest invention. Watt had realized that the loss of latent heat, the heat involved in changing the state of a substance, for example, solid or liquid, was the worst defect of the Newcomen engine, and that therefore condensation must be effected in a chamber distinct from the cylinder but connected to it. Shortly afterward, he met British physician, chemist, and inventor John Roebuck, the founder of the Cairn Works, who urged him to make an engine. He entered into partnership with him in 1768, after having made a small test engine with the help of loans from Joseph Black. The following year, Watt took out the famous patent for a new invented method of lessening the consumption of steam and fuel in fire engines. Meanwhile, Watt in 1766 became a land surveyor. For the next 8 years, he was continuously busy marking out routes for canals in Scotland, work that prevented his making further progress with the steam engine. After Roebuck went bankrupt in 1772, English manufacturer and engineer Matthew Boulton, the manufacturer of the Soho Works in Birmingham, took over a share in Watt's patent. Bored with surveying and with Scotland, Watt immigrated to Birmingham in 1774. After Watt's patent was extended by an Act of Parliament, he and Boulton in 1775 began a partnership that lasted 25 years. Boulton's financial support made possible rapid progress with the engine. In 1776, 2 engines were installed, one for pumping water in a Staffordshire colliery, the other for blowing air into the furnaces of British industrialist John Wilkinson, the famous ironmaster. That year, Watt married again. His second wife, and MacGregor, bore him 2 more children. During the next 5 years, until 1781, Watt spent long periods in Cornwall, where he installed and supervised numerous pumping engines for the copper and tin mines, the managers of which wanted to reduce fuel costs. Watt, who was no businessman, was obliged to endure keen bargaining in order to obtain adequate royalties on the new engines. By 1780, he was doing well financially, though Boulton still had problems raising capital. In the following year, Boulton, foreseeing a new market in the corn, malt, and cotton mills, urged Watt to invent a rotary motion for the steam engine, to replace the reciprocating action of the original. He did that in 1781 with his so-called sun and planet gear, by means of which a shaft produced 2 revolutions for each cycle of the engine. In 1782, at the height of his inventive powers, he patented the double-acting engine, in which the piston pushed as well as pulled. The engine required a new method of rigidly connecting the piston to the beam. He solved that problem in 1784 with his invention of the parallel motion, an arrangement of connected rods that guided the piston rod in a perpendicular motion, which he described as one of the most ingenious, simple pieces of mechanism I have contrived. 4 years later, his application of the centrifugal governor for automatic control of the speed of the engine, at Boulton's suggestion, and in 1790 his invention of a pressure gauge, virtually completed the Watt engine. Later years of James Watt. Demands for his engine came quickly from paper mills, flour mills, cotton mills, iron mills, distilleries, canals, and waterworks. By 1790, Watt was a wealthy man, having received £76,000 in royalties on his patents in 11 years. The steam engine did not absorb all his attention, however. He was a member of the Lunar Society in Birmingham, a group of writers and scientists who wished to advance the sciences and the arts. Watt experimented on the strength of materials, and he was often involved in legal proceedings to protect his patents. In 1785, he and Boulton were elected Fellows of the Royal Society of London. Watt then began to take holidays, bought an estate at Daldalad, Radnorshire, and from 1795 onward gradually withdrew from business. With the approach of his retirement in 1800, and because that was also the year in which his patents and partnership would expire, Watt established in 1794 the new firm of Boulton and Watt, which built the Soho foundry to manufacture steam engines more competitively. During that time, Watt's son by his first marriage, James, gave him anxiety. A youthful sympathizer with the French Revolution, he had been criticized in Parliament for presenting in 1792 an address from the Manchester Constitutional Society to the Société d'Amis de la Constitution, the Jacobin Club, in Paris. After being cleared of political suspicion on his return home 2 years later, however, he and Boulton's son, Matthew, took over the management of the new firm. Watt's long retirement was saddened by the death of a son by his second marriage, Gregory, and the deaths of many of his close friends. Nevertheless, he traveled with his wife to Scotland and to France and Germany when the Peace of Amiens was signed in 1802, and continued to work in the garret of his house, which he had equipped as a workshop. There he invented a sculpturing machine with which he reproduced original busts and figures for his friends. He also acted as consultant to the Glasgow Water Company. His achievements were amply recognized in his lifetime. He was made Doctor of Laws of the University of Glasgow in 1806 and a Foreign Associate of the French Academy of Sciences in 1814, and was offered a baronetcy, which he declined. Legacy. The Watt engine was a defining development of the Industrial Revolution because of its rapid incorporation into many industries. Because of Watt's contributions to science and industry, the Watt, the unit of power in the International System of Units, SI, equal to 1 joule of work performed per second, or 1/746 horsepower, was named for him. Some scientists argue that the design of the parallel motion, or double-acting engine, in 1784 should serve as the starting point of the Anthropocene epoch, the unofficial interval of geologic time in which human activity began to substantially alter Earth's surface, atmosphere, and oceans.